Today we will discuss about group 15 of modern periodic table, in which we will be seeing the first two elements, their properties, general properties of all the elements, and a few products of the group 15 elements, that is of nitrogen and phosphorus, and their properties. That means how they react with other elements and molecules. So to begin with, let us see which are those group 15 elements. As we know that there are 18 groups in the modern periodic table. In group 15, the elements which are there are nitrogen, phosphorus, arsenic, antimony, and bismuth. The atomic number of nitrogen is 7, so its electronic configuration is 1s2, 2s2, 2p3. Atomic number of phosphorus is 1s2, 2s2, 2p6, 3s2, 3p3. Now, since it has entered into the third shell, 3d is also there, but there are no electrons in it. But here there are no d orbitals. There are no d orbitals. This small difference of availability of d orbitals and non-availability of d orbitals results to anomalous property of nitrogen. Anomalous property means a property which is unique to the first element of any group. Like nitrogen can form NH3, phosphorus can also form PH3, arsenic can form ASH3, nitrogen can form NCl3, phosphorus can also form PCl3, arsenic can form arsenic chloride. But NCl5 is not possible. It is not possible. But PCl5 is possible. This is because there are no d orbitals for this inert pair of electron to extend its covalency. These two electrons are called as inert pair. So they cannot come out to any of the d orbitals because there are no d orbitals here. So the +3 valency cannot extend to +5. But here in case of phosphorus, this electron can get promoted to d orbital and can extend its covalency. And hence PCl5 is possible. So this is one anomalous property. And the anomalous property is that nitrogen can form p-pi bonding because they are very small in size. The first element, owing to its very small size, the orbitals are so close that lateral overlapping is possible. As a result, it forms p-pi bonding. And due to this p-pi bonding, the first bonding is sigma, of course. This one and this one is p-pi bond. Due to the formation of this p-pi bonding, it forms an inert gas. Means it is very difficult to break these three bonds of nitrogen. So it forms inert gas N2. But since the phosphorus size is too big, it forms P4 molecules, like in white phosphorus. These P4 units are highly unstable and reactive. They react quickly with oxygen to form P2O5, or we can say P4O10. As there are 3 electrons in the outermost cell, so it can have +3 valency or -3 valency, depending upon with what kind of element it is forming bond. Here, since covalency can extend, so it can form +3, +5, -3. As we go down the group, the atomic radius increases. As a result, metallic property increases. Owing to its metallic property, the acidic nature of the hydrogen also increases. So if we compare the hydrides of p block elements like NH3, it has lone pair of electron and is highly basic in nature. Then PH3, it is also highly basic in nature, but lesser than NH3, ammonia. So in this way, the basic nature's order can be written as in this order. As the metallic character increases, the bond between the metal and the hydrogen becomes weaker, and the hydrogen becomes more and more free to be liberated. So as we go down the group, the basic nature decreases. So we will be studying about this kind of properties under several headings in group 15 elements. We have seen how electronic configuration and atomic radii varies. Accordingly, the ionization energy, say for example, if I take nitrogen, 2 electron, and then so ionization energy, it will leave 3 electron. Generally, it leaves 3 electron. It does not leave these 2 electron because they form inert pair. This can be understood if you see the SPDF method of electronic configuration. 1s2, 2s2, 2p3. So these 3 electrons can be liberated. So if you take out 1 electron, we call it as ionization energy 1. We call it as ionization energy 2 and ionization energy 3. It is easy to take out the first electron as compared to the second and then the third. So the order of ionization energy will be lesser for first ionization energy, then delta H IE2, and then again delta H IE3. So this is the way the ionization energy varies in an atom. In a group, as the metallic radius increases, as the atomic radius increases, with increase in atomic radius, ionization energy decreases down the group. We will not talk about period because we are only talking about group 15. Let us talk about electronegativity. For nitrogen, phosphorus, arsenic, antimony, and bismuth. As we go down the group, atomic radius increases. This implies electropositivity increases. This implies metallic property increases, and hence electronegativity decreases down the group. If you talk about physical properties of p block elements or group 15 elements, nitrogen exists as gas, p4 exists as two allotropes, one single p4 unit as white phosphorus and polymer of p4 units as red phosphorus. They are solid and reactive too. They are highly reactive. P4 quickly reacts with oxygen to form P2O5, which we can also write as P4O10. This is a gas and inert gas. It only reacts, or the nitrogen-nitrogen triple bond breaks only when an energy equivalent to that of thunderstorm. When thunderstorm acts on it, then only this bond breaks. So you can imagine how much strong this nitrogen-nitrogen triple bond is. Now as you go down the group, you get metalloid because metallic property increases. Further down the group, as ionization energy decreases, electron gain enthalpy or electron affinity decreases. Metallic property increases. So this was about physical properties of group 15 elements. Let us see a few anomalous properties and chemical properties of nitrogen again. Let us take it as a question as nitrogen exists as inert gas, but phosphorus is a highly reactive solid. Why their properties are so different, although they belong to same group. Answer to this kind of question should begin with point 1. The first element of any group, owing to its smallest size and high electronegativity, shows anomalous property. For your better understanding, let me define anomalous property once again here. Anomalous properties means unique property which is different from other elements in the same group. Now, what are those anomalous properties? See, nitrogen exists as N2 gas, which is inert, whereas phosphorus exists as P4 and is highly reactive. The reason of that would be because nitrogen atoms are so small that it can form p pi p pi bonding. What is p pi bonding? Nitrogen atoms are so small that after the sigma bond is formed by head-on overlapping, the other p orbitals are able to come close to each other and form pi bond. So this is sigma bonding. This is one pi bond, this is another pi bond, and is formed by px px and pz, pz. So what kind of bond is formed? This is pi bond. So this kind of bond we call as p pi bonding. So this is only possible when the atoms are so small that their orbitals can come closer. But phosphorus is so big that their p orbitals cannot come closer. As a result, they form bonds with the atoms which are available in the adjacent position, like this. So here you see, this is one P4 unit. This is one P4 unit here. So P4 will be either white phosphorus or a chain like that. It can form a chain to form n times of P4, which is called as red phosphorus. Both are reactive, but white phosphorus is more reactive as compared to polymeric red phosphorus. So they all form sigma bond. These are all sigma bond. They are not able to form p pi bonding. And hence the single bonds are weaker than the multiple bonds. This is one reason. Another anomalous property is fourth point. Nitrogen and phosphorus can form NH3, PH3, NCl3, PCl3, but NCl5 is not possible, but PCl5 is possible. What is the reason? The reason behind that I had discussed earlier. I will just make it more detailed over here. This is due to first. The first reason is that nitrogen does not have d orbitals to extend its covalency. Second is the 2s2 electrons in p block elements has reluctance towards bond formation. This reluctance is called as inert pair effect. So this can be defined also. This can be defined like the reluctance of the NS2 electrons of the p block elements in bond formation is called as inert pair effect. So this was described earlier. I have made it little more clear by little more explanation. This will be even more clear when we will be discussing about the orbital structure and hybridization of PCl3, PCl5, all that. So in our next discussion, we will be talking about the orbital picture of various molecules of nitrogen and phosphorus to understand the meaning of extending covalency. What is the meaning of extending covalency? Use of d orbital in bond formation in PCl3 and PCl5, stability of PCl3 and PCl5 and their comparison, and the structure of ammonia, phosphine, and PCl5. That's it for now. Thank you.